Hello everyone, you are welcome to today's class. So in this class, we want to look at logarithm. We just concluded indices. Logarithm, under this topic, we want to look at the following objectives. The first one is we want to look at the relationship between indices and logarithm. Then we look at common logarithms, then we look at examples. So these are the objectives we want to achieve in this video. Now, if you recall, when we're looking at indices, so we talked about this. For example, you have 25. So you want to write this 25 in indices, in index form. So that means 25 means 5 times 5, which is 5 times 5. So we want to write index form, it means, so that would then be equal to 5 raised to power 2. So that means 25 is the same thing as what? 5 raised to power 2. While this 2 is called index or what? Power. I explained this under indices. While the 5 here that we have here is the base. While this is the what? Is the number. So from here we can look at the relationship between indices and logarithm in this way. The power, which is the index, is the log of the number into this base. You can see the power here is the log of this number into the same base, which is base 5. What do I mean by that? So that means log of 25, log 25 into base 5 is what? Is 2. That is the power, that's the relationship. So the power is the answer to the log of what? 25 to base what? To base 5, which is this one. So log 25 to base 5 is equal to what? 2. So there's a way we can also prove this. Another example is this 81, which is what? 3, which could be 3 raised to power 4 or 9 raised to power 2. So that means if we want to write this in log form, so that's going to be log 81 base what? Base 3 equals what? 4. And at the same time, if you have 81, which could also be 99 squared, so which means log, right? 81 into base what? 9 equals what? 2. You can see the relation between the two. So which means we can change indices to what? To logarithm. So that means that logarithm is the inverse of what? Indices. So logarithm is the inverse of what? Logarithm. So we can conclude that logarithm is the inverse of what? Of indices. So which means understanding of indices maybe to understand logarithm. So let's look at this. We have 10 raised per 0 equals to what? 1. 10 raised per 0 equals to 1. We all know that. 10 raised per 0 equals to 1. Now, if we want to write this in log form, so this will give us what? Log. Where is the number? Where is the number? This is the number. This is the number. Just like the case of this one, we have 25, 5 raised per 2. This is the number. That is log 1. Where is the base? 10 is the base. So base 10 equals what? 0. Can you see that? So log 1 into base 10 equals what? 0. Then if you have 100, we have 100. This is 100. 100 is something as 10 raised power 10 raised power 2. So 10 raised power 2. So we can have, so this is the first one. Let's look at the second one. 10 raised power 2 equals to log, will be equal to log the number, which is 100, into base, which base? Base 10, and the answer will become the power, which is 2. Then we can also have 1000, which is what? 10 raised power 3. That means it is log what? Log 1000 into base 10 equals what? 3. And so on and so forth like that. So when we now have base 10, when the log is in base 10, That's what we refer to as common logarithm. So that means common logarithm is referring to what? To logarithm into base 10. You could see that the base of this log n is what? 3. The base of this log n is what? 9. All these ones are not common logarithm. This is not common logarithm. Common logarithm is what? Is into base 10. So which means in this video, and especially for this particular class, we are not looking at other, we are only looking at what? Common logarithm, because logarithm into what? Base 10 is what we want to discuss in details in this class. I hope I'm making sense. So common logarithm is what? Is logarithm. Let me clean this. Common logarithm. So common logarithm. Common logarithm is logarithm in what? In base 10. In base what? In base 10. And most of the time, we don't usually write the log. So for example, if I write log 10, so and I did not put the base, that means that this is in base 10. Anytime you see log and they did not write the base there, it means that log is in base 10 and it is what? Common logarithm. I hope I'm making sense. So that's what we're going to be looking at. So let's look at some examples and see how we can solve them. Alright, let's look at this example before we go into the details of common logarithm. So we are still under here. This one is treating the relation between logarithm and indices. Now the first question says that we should find or write each of the following in log form. As I explained earlier on A, so we have 3, 4, 3 equal to 7 raised by 3. Now the power here will be our answer, and this is the this is the power. Since this is the power, right? This is the base, and this is the what? The number, right? So that means it's going to be log the number, which is 3, 4, 3. Where is the base? 7. So which means the base will be here, 7. Equals to what? The power. This is coming the answer. So we have written this one in what? In log form. So B parts should be easier now. We have 216 equals to 6 raised power 3. So that will then be what? Log what? The number, which is 16, into which base? Base 6 equals to what? The power, which is 3. I hope this is very clear. Good. Then for number 2, write each of the following in index notation. That is, we are doing the reverse of what we did here. So we want to take back to what? To the index form, to indices. So we have log 125 into base 5 equals what? 3. Now, the base, which is what? 5. We then be what? The number, what's the number? 125. 125 is the number. Will be equal to the base raised to power what? The power, which is 3. You can see. So the base in indices is then base in what? In logarithm. That's the same thing. But the power in indices will be the answer to the log of that number in that base. So that means the number equals to the base raised to power what? 3. I hope this is very clear. That is for A. Then for B that we have log 128 to base 2 equals to 7. So to write this one, so this is the base, this is the number. That means the number first equals to the base 2 raised by the answer, which is what? The power. It's going to be power. So that is what is very easy to change from logarithm to what? To indices, and indices to what? To logarithm. Then we go to the last part, which is question number 3 here. So we have find the value of x in the following. We have 3 questions here. The first one we have this. A log 25 base 5 equals to what? X. So the best way to do it is to change this to what? To indices. How do we do that? This is the base. That means the base, this base will carry this one, that is base into what? The power of x equals what? 25. So we can take this one to indices. We have treated indicial equation, exponential equation. This one has led to what? Exponential equation. We can solve this by saying this is 5 raised by x equals to 25. We can take to the base of 5. This is going to be 5 raised by 2. So 5 we cancel 5. Therefore, x equals what? 2. That's the value of x. I hope this is very clear. B, we have log 0.125 into base 2 equals to x. Let me solve it here. So I've solved this 1 and 2. So let's have it here. So what we're going to have there is this. So this is the base. The same thing will happen to it. So it will carry this one, which is the power. So that is going to have 2 raised by what? X equals to the number 0.125. 0.125. So we can also take this one to fraction. This 2 raised by x equals to 125 divided by, we are taking this to fraction, we divide by what? 1000. I hope I'm making sense. Good. That means 2 raised by x equals to, this is 125, this is 1000. We can also take them to what? To the same indices. So in that case, we have 5 raised by what? 3. 5 times 5 is 25. 25 times 5 is what? 125. So that means 5 raised by 3 divided by, over with you. This is 1000. 10 raised by what? 3. So everything together, we can have them to be what? This could be 5 all over 10. Everything raised by what? Raised by 3. Am I making sense? So in this case, we still have 2 raised by x here, which equals to this. So 5 here 1, 5 here what? 2. That is 1 over 2, everything raised by what? 3. So we can take this one to negative index, 1 over 2. We did that negative index, that when you have this, you have minus 3 raised by minus 1. This can be written as 1 over what? 3. So we can take this one back. So in that case, we're going to have 2 raised by x equals to this 1 over 2, we then go 2 raised by what? Minus 1 raised by what? 3. So these are under indices, under laws of indices. Power raised to another power. And the law is that you multiply the powers. So in that case, we're going to have 2 raised by x equals to 2 raised by what? Minus 3. From here, these 2, we cancel these 2. Therefore, x will then be equals to what? Minus 3. So that is the solution to this question. I hope this is very clear. All right. So we move to the last part here. The last question we have here, which is C part of question number 3. So the C part of question number 3, we have log 1 all over 343 base 7 equals what? X. So that means base raised to the power 7 raised to the power x equals to 1 all over 343. So what we are going to do, we are going to take the 7 raised to the power x equals to 343, everything raised to the power minus 1. We have changed this one to what? Negative index. So we now need to reduce this one to the base of what? 7. So we can have the same thing. So how are we going to do that? So just take this 3, 4, 3. So 7 in 34, 7 plus 28. So that's going to be 4. right? So that's 28. 28 minus minus 34, that's going to be 6. 7 in 63, that is 9. Then 7 here, 7. 7 here, 7. Are you with me? So that means 7 raised by x equal to what? 7 raised by 3, everything raised by minus 1. That is 7 raised by x equals to what? 7 raised by minus 3. Power raised to another power, you multiply the powers, right? So that means this 7 will cancel this 7. Therefore, x will then be equal to what? Minus 3. So that is the relationship between logarithm and indices. So in our next video, we are not going to look into in details common logarithm. I explain what common logarithm are. So common logarithm are logarithm to base 10. So other types of logarithm, we're not going to look at that now. So we look at multiplication, division, roots, powers of common logarithm. So that is where we're going to stop in this video. So if you find this video useful and helpful, don't forget to give us a big word, thumb up. And if you are new to this channel, don't forget to subscribe and make sure you put on your notification bell, so that anytime I release video like this, you'll be the first one to have access to it and get notification of it on time. You can share the video with your loved one, your classmates, and your family. So we meet in our next video. Bye for now.